Thank you all for visiting our presentation. My name is Joe, and we have Billy and Jason, who have been working on this project over the last few months. Our project is to focus on network and system monitoring. The purpose of network monitoring would be for schools and businesses or personal small group projects to know when computer and networking equipment is working and how effectively they are working to better meet the user's needs for internet access and utilities. It would be like having someone always checking your car remotely to see what's going on with it and to know when your car may be due for new tires or other maintenance needs before you need them and better respond to you for it if you do need them. The reason to care about this is the sooner a technology administrator can recognize and realize there's a problem, the faster it can be fixed and even prevented before it reaches a point where it can cause a problem. If the network is slow in X room of a building, if the building was being monitored, then you can more easily diagnose the problem and better fix the issue versus you having to contact IT when the internet access is being excessively slow or unable to access files across the internet. May be able to prevent the issue first of the monitored building. If there is an issue for internet slowness or other problems that happens on a specific day or time, consistently over a period of time, it is also possible to find out to make it easier for the IT staff to notice these patterns with most variations of this technology. And let's say there's a sudden and unexpected problem. The network and monitoring system, if set up properly, can alert staff through email or through other means on those specifically monitored crucial areas and begin investigation right away. Prevention is always good, but sometimes these things do come up. We will go into further detail as to why the project was started in the first place. Network monitoring is a tool that is useful for everyone, and the old system is unfortunately no longer with us and no longer updated. The old tools were also missing a few key details that would be better for the current technological world today, such as the information in it and securing the application itself. We looked briefly into getting both Cacti and Nagios possibly updated and bring it back online, as that's what we used to have and had working before. And what we found is that the software definitely has reached its limit in age and didn't have what the modern network is looking for. The interface itself was hard to understand and support was very little to gone for the versions that we had and was something that should be changed. A previous group looked into both Nagios and Cacti and determined its possible replacement could be the next step in what we're looking for in both features and future supports. The tool that they researched and realized was Zabbix 2.0, and we couldn't agree with them more. However, we now have Zabbix 3.0, Zabbix which is now fully released, and 3.0 will be fully supported until February of 2019. And it'll allow for support and questions on any possible errors or new features that come out for it. We focused on the network and internet equipment for a few areas of the ITC network on a basic level and can be greatly expanded to not necessarily all devices, but those that are required to be monitored. The reasoning for not focusing on all devices, as the benefit to time to set up may not be sufficient for everything to be checked. Zabbix 3.0 was released the day we started this project, and as a test, we tried it out and realized how much more stable it was, as well as we had to use it so that the support pipeline could be used to the best degree possible. It's no good to go ahead and buy and customize a new car, only to find that the model that you really wanted was just released, and now you either have to start over or relearn what you just did. Some of the new features in Zabbix is daemon encryption and authentication. In short terms, meaning that the Zabbix system and computers and devices running the software are securing the data as well as the device it's installed to prevent misuse of the data. We're able to view CPU monitoring on a per device basis as well as storage, RAM, and network speed. This can be set up easily on each monitor computer, rather easily through the setup files, and the system will automatically display the information sent to the server PC. Over time, we can view this data to see if the performance is improving. Say we completed an upgrade on February 24th. We can view that data immediately and see improvements in the area over the next few days and have that information that showed it did do something to either its users or its financial staff. We can set up graphs to view data during work hours only if needed, and read various points of data down to per minute from the previous 10-minute marker and is more real time. If needed, we can set up groups so that other individuals besides the administrator can see the data that they want to see right away just by logging in and having it available without giving access to edit the report that is loaded for them. These are just some of the features in Zabbix 3.0 from the previous 2.2 version release, and we'll show some live data and some of the information that we have been capturing. Naturally, the information can be expanded upon and receive more data than what we have displayed. The main scope of our project is to prove that it can be set up and it works, and maybe some future projects can look into refining the information on a per need basis after our basic setup is applied.
Now we'd like to take you on a tour of Zabbix and its many functions. This is the Zabbix login page. It's important to note that Zabbix is a multi-user environment, and you can extend access to other members of the IT department that may have a particular interest in certain parts of the infrastructure or certain devices. You can also even extend access to people outside of the IT department who might want to see a broad overview of what's going on in the network. So let's go ahead and log in. This is the dashboard. This is the default page you reach after you log into Zabbix. This is completely customizable. You can toggle the visibility of the panels, and these specific panels can be rearranged as you wish, and there's certainly other options for these. So let's take a look at some of these sections. The overview page is where you will see the most pressing issues occurring in your environment. That's, for us, is this SNMP, the Standard Network Monitoring Protocol timeout, which is preventing us from communicating with one of our devices. The web monitoring section is where you can have either simple or elaborate checks of what's going on with certain websites from the perspective of certain devices. So this is, for example, is checking to see if the core switch can access the ITC wiki site. And the last check actually indicates that it was unable to reach the site. So if we want to look into that further, we can click on the name and see what's happened over the course of time. You can see that the far end of this graph indicates that the checks were successful up until recently. The latest data page shows you a snapshot of the latest bits of data collected by any device that you're looking at. I have this filtered right now to Cisco switches. Now let's take a closer look at the ITC B107 interfaces data points. So I'm going to expand this section to see the different interface items that are being collected. See that I can look at a graph of any of these things. These, for example, would show me what the administrative status of a given interface were over time. And let's try to find something a little more interesting to look at. This is the incoming traffic on interface 35, and let's look at the graph for that. So this shows us by default the graph of the traffic that has occurred over the last hour. So we can see various spikes in the data that have occurred. It maxed out at 533.73 kilobytes. You might have seen the graph change slightly. That's because this is a dynamic graph and it does refresh when new data points are added. So we can see that this is the most recent data point that we got. If I want to zoom to a different time frame, I can use any of these links to do so. So for example, if I wanted to look at the past 6 hours, I can see that the spikes that we saw were actually pretty inconsequential, and around 6 p.m. we maxed out at 57.92 megabytes a second. So this is quite a large amount of traffic that occurred during that time. I can also move the bar itself to change the 6-hour period that I'm looking at. So if I wanted to look at the 6-hour period on the 13th, I could move the bar to that time frame. I can pick the exact time and calendar date of what I'm looking at if I would prefer to. If I change this to dynamic, I'm not changing the time frame I'm looking at, I'm changing the amount of time I'm looking at. So I can move the time frame I'm looking at up to 4 days, for example. So there's a lot of versatility to what you can do with any given graph interface. This is known as the simple graph interface in Zabbix. So you can see that even with that, there's a lot of customization that you can do to really pinpoint the data you want to look at. Now let's jump over into a different section. In the configuration section, you can set up actions to occur when certain triggers are pulled. You can make various types of calculations on what conditions will pull that trigger, and the conditions themselves can have a number of different criteria. In this simple action, we're sending a message to Zabbix administrators via Gmail. Let's go over to the Zabbix agent, which is a Windows server, and stop that service to cause the trigger to fire. Now if we go to the CPU load graph, we can see the data is certainly still being collected and Zabbix doesn't notice a problem yet. This is because it assumes in the event of a problem that there's a communication issue. But now that we sped time ahead a little bit, we can see that the Zabbix agent is actually unreachable and it's caused a trigger to fire, and an email has been generated from the network monitoring ITC address. Now I can acknowledge that and explain a reason why that occurred, and the alarm will. A beneficial part of this project is we were able to collaborate with the group that's going to be following us, who worked on creating a Linux mirror as part of their Capstone project. So this involved adding their Linux host into our group of monitoring devices, and then we instituted a number of checks that occur to ensure that the Linux mirror is functioning properly. This is if the device is available on the network, if it has enough free hard drive space, and if it was able to successfully sync the updates from the other Linux mirrors. And we just want to thank you again for attending the presentation, and we'd like to extend a special thanks to the ITC faculty, especially Ben Franksky and Tom McGardell, and we're happy to answer any questions. Thanks again.